What's up, pre-calculus? I'm just teasing. Rico told me to spice it up. All right. So you guys started writing these basic differentiation rules the other day, and I won't keep it up for very long because this is a video. You can pause it. All right. But I believe you probably got to about here, and then the rules were actually down here. So I'm going to scroll this down and talk about these rules real fast. All right. And by the way, you guys are going to love me after today because you've been doing these the hard way and the long way, but you needed to do that so that you can appreciate the nice way. So this is how we write a derivative, all right, as d over dx. There's lots of different ways. You could do d over dx. You could do f prime, which is really what I prefer, but you need to see it this way too, and these are the way the rules are written. So you have a constant rule where if you take the derivative of a constant like 12, 4, 7, something that doesn't have a variable, all right, that's just 0. All right, let's say you have the power rule where you take the derivative of something raised to a power. Well, all you do is you pull that power to the front, and then you decrease the power by 1. All right, then you have your constant multiple rule, where if I have a constant in front of a function, it's that constant in front of the derivative of that function. All right, the sum rule, if I have one function plus another function, I could take the derivative of the one and add it to the derivative of the other. All right, your difference rule, same thing as the sum rule. And then the derivative of sine is cosine. The derivative of cosine is negative sine. You will need to know those because I am not giving them to you on a test. So let's dive right in. All right, number 1, I'm wanting to take the derivative of 2x squared plus 7. So here I have two terms, right? I have one term, and then I have the second term. You do them each separately. So remember the rule is you pull this down to the front. So I'm going to pull the 2 down to the front and multiply. So this would be 2 times 2x. And then you decrease this by 1. So I subtract 1 from it. When I do that, this would be 2 times 2 is 4x to the first. We don't write a 1 right there because it's understood to be there. When I take the derivative of the constant, that just equals 0. So the derivative of 7 is 0. So the derivative of this whole thing is 4x. All right? And just for kicks and giggles, I'm going to show you what you have been doing. You've been plugging in x plus h for that, right? Minus your original function all over h. So this would be 2 times x squared plus 2xh plus h squared, which would give you 2x squared plus 4xh plus 2h squared. Then you got your plus 7 minus 2x minus 7 all over h. The 7s would cancel, right? And then you've got 2x squared and your 4x. Oh, I forgot my squared here. Sorry, guys. 2x squareds will cancel. So then you can cancel an h, right? Then you would plug in 0 for that h, and that would give you just 4x. All of this work can be simplified to this. And this is why you guys love me now. All right, so you pull the exponent down, you multiply it times whatever is in front, that gives you the 4, and you decrease this by 1. Then you do the derivative of everything else. So if I'm looking at this next one, I pull the 2 down. 2 times 3 is 6. X to the 2 minus 1 is 1. The derivative of negative 7 is 0. And the derivative of cosine is negative sine. Sorry, y'all, my little pen is not wanting to work. And that is my derivative. All right. Oh, something that I did forget to do, though, because I'm rushing through this, is to show that this is the derivative. So make sure in front of these that you put derivative notation, and we're going to go with f prime of x equals, all right, to show that this is the first derivative, all right, even though it's just a little prime symbol, it's not a 1, all right, it's like an apostrophe, all right, so this would be f prime of x is equal to this, all right. So number 3, I pull this down to the front. This would be 3 times 1, which is 3. X to the, decrease this by 1, so this would be to the second. So f prime of x is equal to 3x squared. All right, number 4, same thing. I'm going to pull that negative 4 to the front. Negative 4 times 1 is negative 4. X to the negative 4 minus 1 is negative 5. Now, we do not leave negative exponents. So remember, all you have to do is change the sign it's on. If it's in the numerator, put it in the denominator. That changes the power to be positive. So this would be negative 4 over x to the positive 5. So this is in the numerator, move it to the denominator. So f prime of x is equal to negative 4 over x to the 5th. All right, so I have 3 terms here. I'll do them all separately. 8 times 2 gives you 16. X to the decrease by 1, 7th. Plus 7 times 3, 21. X to the decrease by 1, 6. Minus 6 times 9, 54. X to the decrease by 1, 5th. So f prime of x is equal to that. All right, so pull this to the front. 4 thirds times 2 gives you 8 thirds. X to the 4 thirds minus 1. Now remember, when you're subtracting 1 as a fraction, it's just that denominator, top and bottom. So 4 minus 3 would be 1 over 3. All right, and to make this a little nicer and more appealing, I'll take it like this. All right, but this would also be the same as 8x to the 1/3 over 3. All right, I'll take it either way. Either way is good with me. All right, so look at this. Well, the derivative of sine x is cosine x. So this will be negative 8 cosine x. And the derivative of cosine x is negative sine x. So this will be negative sine x. And I'm done. All right, so let's change it up just a little bit. So now we have a root. And if you'll recall from Algebra 2, right, because we all remember that so well, if you recall, we need to change this root to have an exponent. So what you do is, this is x to the first, right? So I would have 1 over x to the, this would be 1 over your root, which is 8. So the 1/8 power. Now, I don't do any kind of derivatives when I have stuff in the denominator. So what needs to happen is I need to move this up into the numerator by changing the exponent to a negative. So this would be 1 times x to the negative 1/8. Now, we don't really need this one here. I'm just putting it there for purposes, so we can see that it's still there. So I'm going to pull the negative 1/8. Now that we've got it set up, I can take the derivative. Negative 1/8 times 1 is negative 1/8. X to the, if I subtract 1, that would be subtracting 8 over 8. So negative 1 minus 8 would be negative 9 over 8. Okay? So now that I've taken the derivative, I don't leave a negative exponent. So this right here is in the numerator, because remember we talked about how you can write this with the x on top. So this would be like x to the negative 9/8 over 8. So I could move this to the bottom but change the exponent. So it would be negative 1 over 8 x to the positive 9/8. And I will let you leave it that way. If you were going to put a root with it, it would be 8 times the 8th root of x to the 9th. All right. So I will also take that as an answer. But this is fine with me. All right. Last page of notes here. We only have 3 left. All right, so again, we don't do it with the root like this. We need to change that to an exponent. So this would be x to the, this is the first power. So 1 divided by your root of 3. This guy over here, he's fine. So now we're ready to take the derivative. So I've got 1/3 will come to the front. And then 1/3 minus 1, so that'd be minus 3 over 3, would be negative 2/3. 9 times negative 5 would give you negative 45, x to the decrease by 1/8. But we do not leave exponents as negative. So remember, this is in the numerator. So we'll simplify this and say this would be 1 over 3x to the 2/3 minus 45x to the 8th. And again, you can leave like that. If you want to put a root, this would be the 3rd root of x to the 2nd. And I think most of you are pretty good with your fractions and stuff, but if you're not good with this, just say 1/3 minus 1 in your calculator. It'll tell you that that's negative 2/3. I mean, you don't have to put a lot of effort into that if you don't want to. All right, number 10. Nothing is wrong with this 7x to the 3rd, but I don't do any of the derivatives until I've gotten everything out of the denominator. So this would be minus 4 to the, well, this is x to the 1/5. So if I move it to the top, it would be x to the negative 1/5. And this one would be x to the negative 4th. So now I'm ready for my derivative. 3 times 7 would give me 21, x to the decrease by 1. Negative 4 times negative 1/5 would be a positive 4/5 times x to the subtract 1. So this would be minus 5 over 5. So that would be negative 6/5 plus, because this is going to be negative 4 times negative 1, which gives you a positive 4, x to the, oh, don't do what I did. Negative 4 minus 1 is negative 5. So now we just need to change these negative exponents. We don't want those in our problem, our final answer. So this would be 21x to the 2nd. This x to the negative 6/5 will move to the bottom and be 5 times x to the positive 6/5 plus, this would be 4 over x to the positive 5. And again, you could write this x with a root, a 5th root of x to the 6th if you so chose. All right, last one. So again, we want to make sure everything is where we could go ahead and start taking the derivative before we do some, because you don't want to take it and then not remember that you took that one already and not the other. So this would be x to the 1/3 plus 4 times 2 is 8, x to the decrease by 1 plus, get this off the denominator, so this would be x to the negative 6. Now take the derivative, pull the 1/3 to the front, so this would be 1/3 x to the subtract 1, so that would be negative 2/3. 8 times 3 would be a positive 24. X to the second. All right, and then you've got a negative that you're going to pull forward, so we don't want that plus. So we'll have a negative 6x subtract 1 would give you negative 7. Now you just need to get rid of those negative exponents. So you have f prime of x is equal to, this x to the 2/3 will move to the bottom, so this would be 3x to the positive 2/3. Nothing wrong with your 24x to the second. Oh, y'all didn't catch me. No, I'm just teasing. All right, I told you not to take the derivative of that, and then I took the derivative of that. So I've already done this one. So let this be a learning lesson to you. If you take the derivative of one without doing the other two, then you think that you need to take the derivative again, but you don't. So just to reiterate here, I already took the derivative of this one right here, so I didn't need to do it again. You only do it once. All right, so this should be 8x to the third. 4 times 2 is 8x to the third. All right. And then you've got to move that negative 7 to the bottom, so that would be 6 over x to the 7th. So I apologize. I totally did that on purpose, just so you guys would know, what you're doing wrong. All right, so your homework is very similar to that. I don't think that you'll have any trouble. Just remember, don't do the derivatives until you bring everything down to where you can go ahead and take the derivative, all right? Guys, have fun without me.